So reaction of an aldehyde with Grignard reagent. So we have PHCHO, and when this compound reacts with CH3MgBr and the solvent used is ether, and then further we do acidification. Final product in this reaction is alcohol, and this time this is a 2-degree alcohol. Now if you see this product, that is alcohol, this carbon is a chiral carbon, because it has 4 different groups attached to this carbon. So this is because 4 different groups are attached. So this means this compound, that is 2-degree alcohol, is optically active. So this alcohol is optically active, and there are 2 stereoisomers are possible for this compound. So there are 2 stereoisomers are possible for this alcohol. And basically these 2 stereoisomers will be enantiomers. So a pair of enantiomers are possible. Now the question is, which enantiomer will be formed in this reaction? So either R configuration or S configuration will be formed, or both will be formed. So question is either R configuration or S configuration or both. The same thing we can say in terms of optical rotation. So either plus optical rotation or minus optical rotation, or we can have plus as well as minus, both. Now to answer this question, we have to see the mechanism of this reaction. So mechanism is important to say something about the stereochemistry of this reaction. So only mechanism will answer this question. We'll tell about stereochemistry of this reaction. So in the first step of this reaction, basically attack of a nucleophile, and this will act as a electrophile. So first step is nucleophilic attack. So we have PHCHO and we have CH3MgBr. So we will have CH3 minus. So this will attack on this carbon, and at the same time we have to open this bond. So we will have PH CO minus and CH3. So this is the first step, that is nucleophilic attack on carbonylic carbon. So this is nucleophilic attack on carbonylic carbon. Now if you see this carbon, hybridization for this carbon is sp2, and the geometry of this molecule is triangular planar. So this is triangular planar. So we can show something like this. Now CH3 minus can attack from top face, or it can also attack from the bottom face. So there are two possibilities. We can have a top attack or we can have a bottom attack. So if top attack happens, we will have this product. Now if bottom attacks happen, we will have this product. Now if you see, these two products are mirror image to each other. So these are mirror image. So basically in this reaction, we will form both product in equal amount. This is because top attack and bottom attack is equally likely. Top attack and bottom attack is equally likely. So both product will be formed in equal amount. So this means I will have this product and then we have CH3O minus as well as this product, and we will have both products in equal amount. This means this is 50% and this is also 50%. Now further if we do acidification, we will have corresponding alcohols. O minus will gain a hydrogen and finally we will have an alcohol. So we can say the final product is a racemic mixture. So what is racemic mixture? So racemic mixture is a mixture that contains both enantiomers that is basically mirror image So these are enantiomers. So these two are enantiomers. We have an enantiomeric pair. So this is a pair of enantiomer. So both contains. So racemic mixture is a mixture that contains both enantiomers in equal amount. And racemic mixture will have 0 degree optical rotation, that is optically inactive, because if one compound rotates plus, that is in the clockwise direction, another compound will rotate in anti-clockwise direction. So this means we can say racemic mixture is optically inactive. Racemic mixture is optically inactive. We can ask a question here. Let us say if I have a ketone and if this reacts with EtMgBr, further we do acidification, what products we will have? Once again we will have an alcohol, and this time we will have 3 degree alcohol. And we will have a racemic mixture because both products will be formed in equal amount. So we will have a racemic mixture. Now let us say if I have this ketone now if this is treated with pH MgBr and medium is ether, and the next is acidification. What will be the product in this reaction? Again we will have an alcohol, and this time we will have a 3 degree alcohol. But the final product is not optically active. That is, we will have only one product. This carbon is not a chiral carbon. So we will have not a chiral carbon. So we will have in this case only one product. We will have only one product. And the product is optically inactive.